Good afternoon, everyone. We are now in our session number 8 of day 3, and we have our speaker Dr. Thakkar, Assistant Professor, Marwadi University, Gujarat. Good afternoon, sir.
Yes, good afternoon.
Good afternoon. Yes. Sir, we can start our session, sir.
Yes, sure, no problem.
Okay. Thank you, sir.
Okay, yeah, so I'm going to share my screen.
Okay, sir.
Can anybody please confirm the screen is visible or not?
Yes, sir, it is visible.
Yes, thank you very much. Good afternoon, everyone. Let me switch on my video as well. Yeah, I hope everything seems fine, my audio as well as the video.
Yes, sir, it is fine.
Okay, so I'm very much thankful to CSIT Durg as well as the organizers for inviting me to deliver a talk. And I'm hopeful that my talk will be beneficial to others as well. So today my topic is deep learning, its application and case study. And there was slight modification in my affiliation. So previously when I invited, I was working with SRM University, but currently I'm working as associate professor in Marwadi University, Gujarat. And I'm HirenKumar Thakkar, completed PhD as well as postdoctoral from Chang'an University, Taiwan. And I'm working in a different area as part of my research, something like opinion feature mining, healthcare data analytics, as well as the cloud resource management. So if anybody is interested to have some sorts of collaboration in the research, then they can please kindly contact me. I have provided my URL of my website. So you can go through my research areas, publication, and collaborations, and I will be open for any sorts of collaborations for the progress. So, without like much uh, devoting the time on the introduction, I'm directly jumping into the topic because this topic of the deep learning is very wide. In the recent past few years, the topic has attracted researchers as well as the industry persons to focus more because of its applicability in the real life scenarios. So therefore, it is the right time to study the deep learning as well as devote more energy so that we can have the useful applications as well. So that's why I have not only focused on the only the deep learning concepts, but also the corresponding applications where it is predominantly applied, as well as to see the case studies. So before we formally define about the deep learning, it is very important to understand from where we have started this process and currently at which position we are. So broadly, if we say this artificial intelligence is like the main tree. And before we coined this term artificial intelligence, there was a commonly known term as intelligence. And during 1950s, okay, the mathematicians, especially focusing on the statistical learning, they have started to think that can is it possible to embed or instill the intelligence into the machine, or can we define some mathematical model which can react based on the current situations? So there, the thought has started by the Samuel. If you have uh, listened to this particular game, the checkers, which is very popular game. It seems like a very similar to the chess, But the checkers game, it requires the ability to take the decision in each and every step, similar to like a chess. So that was early euphoria. It has given or it has steered the excitement of doing some task by the machines, because ultimately we as a human always want that if somebody take over our task, so we can always devote our time to some productive activity. So very small example I just have experienced myself when I was in Greater Noida for 2.5 years with Bennett University. So usually we have to commute to the Delhi from Greater Noida, which takes around 40-45 kilometers to run. And we all know that in major cities there is huge traffic problems. So, like, see, I'm just simply driving during that 2-3 hours and spending my important time on the roads and without doing any productive work. So, can we design some like automation in the car so that the car driving, which is not a productive work for us, and we transfer that to the machine. That machine will take care of the entire driving process destination, and we can just sit beside. Either we can go for the reading the newspaper, we can prepare the presentation slides, or we can design some research concepts. So that 2-3 hours, if we just take on a daily basis, it seems very small, but on a monthly basis, like a 60 hours, and on a yearly basis, around we can say 700 hours of time can be saved on a one-way trip. Again, you will just come back again, 2.5 hours are simply you are spending on a road. So that initial excitement was that if we can somehow transfer our work to the machine and it carefully taken over by the machine, then we can have some sorts of time for the productive. So there was a very we can say the excitement. But that was very limited to some specific games like the chess, checkers, AlphaGo. But then after like the advancement of happen in the artificial intelligence, we are now we have seen in the past few decades, like around 1980s after, we have the emergence of the machine learning, and it has for not it has gone beyond the game environment, and we have started focusing on the each and every daily life applications where we can apply the machine learning, space and supervised, unsupervised, it doesn't matter. We started to doing that, and one of the very mature application we can say in the machine learning is nowadays this spam filtering. So most of us are now using Gmail, Yahoo Mail, or Outlook, like Microsoft one. Whenever we open the spam box, and we usually see those kind of emails, are almost all the emails or most of the emails are the spam, which are correctly classified and given this spam category, and all the useful emails are in our inbox. And in very rare cases we notice that our important emails has been classified and gone to the spam box. But nowadays we can see that this application is much more stabilized because of this machine learning and evolving applications. So we cannot stop here that the application has been matured, so we should not invest energy on that. But the thing is that the attackers are also becoming the novel. They come with the novel ideas to sow these spammer, which is a spamming model, that I am a legitimate email and I should go to the inbox rather than going to the spam. So they are coming up with the novel ideas to identify them as a designate them as a legitimate email. So what the thing is going, this is ever going process, means that each and every day this machine learning algorithm, like it's like mostly the supervised one. So more and more examples are being added on a daily basis, so that the machine learning model is adjust itself that which one is legitimate, which one is not legitimate, and accordingly that goes for the I guess the proper classification. So you can see the timeline. We started from the 1950s, and during the 1990s we started in the 2000s designing the applications. But the fundamental problem when this AI term has been coined was that the thought was to create kind of a robot which acts like a human, which can has the power of listening to react based on the situations. Okay, they can speak, they can understand what the others are speaking, it can visualize the thing, it can identify the objects. So those purposes couldn't be satisfied with the just merely having a machine learning models. So again, there was some sort of advancement, and after this to 2010, we gone into that like the area which has come we can know as a deep learning. So the thing is that the artificial intelligence has stirred the excitement. Machine learning has begins to flourish, and in the deep learning we have the breakthroughs which drives the AI boom. So nowadays, we can have everything, like every domain, whether it's precision like the crop yield detection, disease detection. Like in the corona, also we have started applying the deep learning techniques to detect whether the person is infected or not. So you just name the application, and you may find that either directly or indirectly there is an application of the deep learning, either to find the object. Okay, on a table, if I just take a picture and I want to identify, so I can identify that this is my cell phone. Okay, this is my wallet. So there will be a captioning will be there. So when you take a picture of the table and you apply the caption deep learning, you can caption each and every individual objects also. So that has a very strong foundations over there. So this is the journey. I have spent much time on this because I wanted to know that from where we started and what and where we are currently. So broadly, if we just see the like in a broader sense, the applications of the deep learning, or we can say the artificial intelligence also. So I go with the computer vision, then the speech and audio, and the natural language processing. Now, the thing over here is to understand is that for human, okay, it is very easy to have the object detection, and the computer vision capability is more. For us, the speech is natural language processing. But for us, like the computation is very difficult. So if I just give you two numbers, like you multiply these two numbers, 45873 multiplied by 78231. So for us, it takes time for the computation. We are not habitual to do that. But if somebody say, "What is this?" Then we can easily say this is a cell phone. So it's object detection as well as object recognition is very natural to us. But the computation is not very natural to us. We have to spend some energy or to spend some time on the computation.
Sorry to interrupt you, sir.
Yes,
Sir, but the PPT is not visible.
that's why I just in the beginning asked that is it visible or not. Anyway, let me
Yes, sir,
share.
sir. In the beginning it
Let
is
me
visible,
reshare.
but now it is not visible.
Okay, let me check again. Okay, now is it visible again? Or some issue is there?
Yes, sir. Yes, sir, it is visible now.
Fine. Thank you very much. Just just confirm because I'm going into the presentation mode now. It
Yes, sir.
is yes, in the presentation mode is also visible, right?
Yes, sir.
Okay. So, like broadly, when we classify the applications, so I was explaining the difference, like between the human and the models that we are designing. So the thing is that for us as a human, the computation is not natural to us. It takes a time-consuming process, and but the object detection, recognition, the speech and audio. When we listen to someone, okay, we can easily understand what he or she means to say us. But there is a contrary difference with the computer. For the computer, the computation is very natural. When we give two large numbers for the multiplication, we can get the instantaneous answer. But when we okay nowadays it's very common, but previously like few years before when we give some these objects, we locate give like some objects in front of the camera and we ask okay we design some models. So object detection it was very difficult because there are several background things you may capture. So object detection, object recognition was the things which is very difficult for the computers. But with the help of the deep learning, now we are moving in that direction. So the first application we see in the computer vision, so image classification. So in a same picture, okay, you are just taking a picture in front of the Taj Mahal. So you might be also capturing other things like the flowers, flower gardens. So some flowers will be in the picture. The human as a we just in front of the Taj Mahal, then the sky in the rest of the portion. Fine. So in a same image, either sometimes we need to classify or we can say that detect the object, like this is a person, this is the Taj Mahal, these are the flowers, this is the tree, same picture, same thing. So there is an object detection part of the application in computer vision. Then image classification also, it has to understand this is cat, this is dog, this is aeroplane, this is like a pillar. So those kind of applications are popularly covered in the like deep learning. In the second area where the deep learning is like the speech and audio, where two things are very prominent, like voice recognition as well as the language translation. So I just give like analogy like voice recognition, because nowadays we are using the smartphones, and we have the different ways to unlock our smartphone. We can use the pattern so that we can unlock, we can enter the pin code, and nowadays we have the sensors or like thumb impression, so we just put our thumb impression or the fingerprints, and it can unlock. There is another way also, the voice recognition. Like if there is a, so let's say I just example is the password is Ganesh, my password is Ganesh. So when I speak Ganesh, okay, so it has to understand, it has to recognize the legitimate voice of the owner, rather than if somebody is speaking the Ganesh, so it has to differentiate. So that is the application, and the language translation is the most like the crucial application, which I also find it very useful when I was in Taiwan for my PhD as well as postdoctoral. So the main problem was the Mandarin, because we never have I never have an exposure to the Mandarin. So for me, everything is like just a pictures in a different like the crossing lines, and I was very wondering that what to how to for the daily activities. So the handy tool was for me is the Google Translator, and the Google Translator initially was that I have to copy the text, I have to paste. But sometimes when you go into the market and you see the signboards, or when you see the banner in just front of the store, so we cannot just type that Chinese characters because we don't know how to type. So they have this application. So when we take the pictures of that like the language signboards, so from that it automatically recognizes each and every characters, and it forms that kind of Chinese statement. I just need to translate them into the English. So language translation is also one of the applications where we are using these models, and as well as the natural language processing, where the recommendation engines and the sentiment analysis. So there is also, so these are the like the broad applications which are currently in the focus. And in the sentiment analysis, we can say it's a very huge commercial business the people are making out of it. So for them, example is like the Amazon e-commerce websites. So like billions and billions of the reviews are being thrown or generated or supplied by the users onto the websites. Now, as a e-commerce website, for me, everything is like to gain more and more business and revenue. So I need to figure out among those like say 10,000 products which I'm selling onto this entire e-commerce platform. I need to figure out that which products are currently in the demand, or which products are in a demand but are not performing as per the expectation. Suppose a new Xiaomi phone is launched, Mi phone is launched, and the initial euphoria was very good that it will be having these features, this many configurations, but in the actual, the people are not happy with that. So that kind of feedback I wanted to have. So what I will do, I will just simply scroll each and every reviews from that, and the reviews are not in 100 and 1000, but 10,000, 100 million, 1 million reviews are there for like several products. So I will crawl those, and for that I have to go with natural language processing, and ultimately I will say the overall sentiment for this product is like 70% positive, 80% positive, like that. And based on that, I will also generate the recommendation engine. So if you like this Mi phone, then there is another similar phone in the another brand, like say the Nokia or Samsung, which is better compared to this particular brand and affordable also near to that price. So we can see the applications considering the precision agriculture, video captioning. So video captioning means that suppose you are watching a film of some different language with which you don't know about the Spanish, suppose Spanish movie. Okay, so there you can apply the natural language processing. So the each and every sentence is being spoken in a Spanish language by the actor or actress. Instantaneously, that will be translated into your own language, and there will be a caption. Okay, so that you can also have different applications. So you think the application, and there are the ways over there. Behavior prediction is also one of them. So Again, that was the broader applications, but when the areas, when we say, okay, those applications are either divided into the detection, prediction, as well as the generation. So, like in the detection, okay, first of all, what the target is to detect something. Okay, if I give, if I present like a snapshot or a picture, so it has to be objects need to be detected. The text and speech. Okay, so when you are presenting, let's say the physical paper, and you have to identify the characters, optical character recognition, that is an application. So that is part of the detection. First we detect, after the detection we go for the digitization, we design the models, we go for the prediction. And after the prediction also, sometimes nowadays the machine learning are also generating the things also. So main areas. So in the detection we have the text and speech detection. If you don't detect the speech, you cannot, okay, respond. If the my cell phone unable to detect my speech, what I'm speaking, whether I speak Ganesh or Ganesha, if it and unable to differentiate between them, there is no application possible for unlocking the phone. Image interpretation, fine, you are standing in front of the Taj Mahal, so it has to be interpreted that the person is in a kind of someone standing in front of the monument, you are on the mountain, you are in front of the sea beach, or where you like kind of an interpretation. So that can be also provided. Human behavior and identity, of course, the emotional recognition nowadays, and that is very prominent also because if you just check the human behavior, then sometimes we also solve the problems of that suicidal tendency from the, because regularly if you detect the person not happy, is more or less sad or upset, then there might be some tendency that the people may go in another way also. So that is also helpful. The abuse and fraud detection, several like the social media platforms are now like having this problem to tackle the abuse on that platform. So Twitters and Flipkarts are being like given specific instruction by several countries to control the abuse on their platform so that there is no problem the country will face. So these are the open areas and research issues. Like in the prediction also, we go for the recommendation that this product is good or not. Individual behavior and the condition prediction, the collective behavior condition prediction. And in the generation, okay, so sometimes we need to generate the visual arts, music, text, and design. So I will give a specific example for them also. So the first in the detection, so the text and speech detection. Okay, like the prominent example is for the language translation. So if I say, where is the Taj Mahal located? So there is a first it has to detect the text and speech, and then after it will open the Google map and will locate us. So voice command based system, we can say. Then the analysis, like the human behavior detection. So that is we have a good application of this in India because we see nowadays the protest and the crowding is normal sometimes during the like in the political areas, like in Delhi also, like regular basis we can find some sorts of political rallies as well as crowd to protest something. So now that crowd is a normal crowd or abnormal crowd, it's a violent crowd or not. So it's very important to decide, because if the crowd is normal, then it's fine. There will not be any law and order situation problem. But if the crowd is some sorts of violent or having some different behavior, then we have to, like the as a government, they have to arrange the protection so that the other normal publics won't get affected, or there won't be any like problem with the like public property. So that analysis of change in the sometimes the initially the crowd is normal, but gradually the crowd is becoming abnormal. So that behavior detection is also one of the important, and the reporting fraud and abuse also. So like after this crowd like detection, there is also the applications for the individual behavior detection. So I usually give this example in my class also, that suppose as I'm a teacher, okay, I wanted to teach a particular important topic of my subject, and I want that most of the students pay attention. But somehow, okay, the time is like something like that. The time is just day of the cultural day festival, like each universities might having. So most of the students are engaged in one activity or another activity. They are preparing for some cultural programs. So their overall mood is not to learn something, but their overall mood is to have some sorts of preparation. So if I somehow understand the behavior of my class individual, I will, what I my overall application and project we can think of, let's put some cameras into the class, and that camera will constantly like generate the video stream, and from the video stream I will try to detect the overall behavior of the class, whether the class is happy or whether the class is being bored, or like what kind of behavior. So accordingly I can design my like the entire 1 hour duration. So instead of teaching the hardcore concept, what I will think, I will just gradually start by discussing the topics that during my days the cultural activities are being held. It will happen this way, and slowly I will take them into the my subject, and again I will move towards the different um, like activities. So that kind of prediction we can do, so that we can deliver the subject also in a nice manner, as well as we don't feel that the students are not paying attention, like those things. And the collective behavior we have seen in the previous slide also, to detect the abnormal as well as the normal crowd. And this is very important, like the generation. So far what we were having is like either already something is exist, and from that we are trying to detect, or whatever the existing material we have, we analyze them and try to go for the prediction, such as the, let us say, recommendation. But so far we have never generated the data was already available to us. Now this is the third dimension of the area where deep learning is application, is the visual art, as well as the style transfer, as well as the text summarization. Thing is that after this emergence of the social media websites, it has captured our imagination to present ourselves in a different way. So obviously we can differentiate the photo card in an Aadhaar, photo of a person in an Aadhaar card, and the photo of the same person in a Facebook. Okay, so you can't make out that this is the same person which is in the Aadhaar card. So why this is happening? Because of nowadays we have the access to the several different tools which are easily and freely available, where we can decorate ourselves. Okay, we can put different styles to that. So on the left hand side we can see that there is a girl, and there is another, like say, the picture, and it has applied the style transfer, so that the same picture you can see on the right hand side, the girl with that different style together has been presented. So that help us to garner the so many likes and the comments on your Facebook. And we as a humans are very self-centric. So the Facebook, what this Facebook are doing, Facebook, Twitter, this Instagrams are taking the advantage of our self-centric nature, right? When I get the 100 likes, then I will be more happy on that day. And if I get the 100 likes, but my, like say, my friend is getting 1,000 likes, then I will be sad even if I will get the 100 likes. So what the people, there is a race against to the take the like to draw the attention of the mass towards you, that you are doing something. And for that it gives the okay, the emergence of such applications of the visual art style transfer. The same is applicable to the music, that is a style transfer in music. So already existing a music and you want to change that to the hip hop, so you can just fusion them, you can have that style transfer. So even the you can say the normal bhajan, you can also change into a hip hop bhajan nowadays. That's possible because of this style transfer. And the third is very important, the text summarization. Don't have a time nowadays. Okay, even if you spend 2 hours on a like social media website, but when somebody will ask, okay, do you want to do this, and we say I don't have much time. So the thing is that in this scenario of having no time with anybody, so if someone can give us the gist of the entire things, suppose a novel, if I want to, I don't want to read the novel. It's let's say 5 days work for me. But if somebody can give me the gist of the this entire book, that is what we call as a summarization. So we can take a judgment. So before reading the book, okay, before spending 1 day and understand this book is very boring, this book is not interesting. Somebody gets the what is the overall idea of that book, or what is the prominent news story, instead of reading the 10-page newspaper. If somebody says these are the important news, are there in the today's newspaper, then this kind of summary is very important nowadays. Before watching a 3 hours movie, 200 rupees, if somebody will confidently give us the summary of the like a movie, if it is not a suspense movie, okay, normal. If suspense movie, if the summary is given, then not any not beneficial. So the summary is very important, and there also we are generating. So already there is a text. There's a 100-page novel, and I'm generating that on a one-page summary. So this is also kind of a generation, music generation, visual art generation, text generation. So there, these are the applications. Okay, I have since how my topic is deep learning application and the case study. So I'm discussing these are the different applications. So specifically on the airline industry, now you can see where we have reached using this deep learning. In an average flight, we still have this captain as well as the first officer. Those are the pilots. Okay, now most of the work over by the computer, but there are two important things which are still we are not okay, which are not given to the computers are the takeoff and landing. So only these two things are there. So during the takeoff you need a pilot, during the landing you need a pilot, but once you achieve certain heights, when you are stabilized, then entire computer will take care of the work, and the pilots are simply sitting and monitoring the different situation whether these things are okay or not, so they can have a tea, coffee, etc. But now this technical university of Brunswick, okay, so they have designed a model of so there they have started applying the AI pilot, so which can clearly see the runway and lands automatically, and this has already happened. Of course, it is just in a prototype model and it had not been commercialized, and several different testings will be go, but we are moving in that direction. So in future, it might happen that we have this AI taking off the plane, okay, and they are moving, and the landing is also entirely taken care by them. So that is possible in the near future. Then another application in the same airline industry is like virtual AI enabled flight attendant. So far we have those flight attendants, and usually the problem is that when you are traveling a far away country from here to, let's say I'm traveling to Europe. So if I'm going by the Lufthansa or in, let's say, Air France, so most probably the flight attendants must be French people or maybe European. So they may not be knowing the Indian culture, Indian languages, and sometimes it's not like the educated persons are traveling. Sometimes the people uneducated, they don't know English. They may also traveling. So for them, it is becoming quite difficult to communicate and ask for certain requirements. So that kind of problem is normal when there is a lack of communication between the two different languages. So, like with the help of this deep learning and natural language processing, we might have future virtual AI-enabled flight attendant, so which can provide the personalized recommendation based on your ethnicity. Like for India, we greet using the namaste, right? For in China, when I studied in Taiwan, so they say ni hao for your like for the first interaction, like we say namaste. So the choice of salutations will be there. If you are from the African countries, we don't know, but they might have some salutations. If you are from the Japanese culture, you have the different salutations. So if somebody will greet in our own language in a different country, then we feel that okay, we feel some sorts of personalized and happiness. Okay, so choice of salutation, then food preference, irrespective of the countries we go. Sometimes we like the Chinese food, but those Chinese foods are made in India are quite different than the Chinese food we available in China. So for me also, for the first 1 year, it was quite difficult to digest that this is how can be this a Chinese food. We have eaten a complete different Chinese food, but that is a modified Indian version. So food preference, in spite of we are sitting, let's say, in front of the sea beach, very nice, beautiful sea beach. Okay, we are sitting, but if our stomach is empty, okay, we don't enjoy that particular place. Right. So food preference, if we get food of our choice, then it is quite like it makes us quite happy. So You can have the personalized salutation, food preference, movie preference. Also, you can provide liquor preference if you are having that interaction with the crew in regional language. If the flight attendants can speak Gujarati, let us assume that I'm traveling to USA. The like flight attendant is from, let's say, France, but she is speaking, let's say he or she is speaking Gujarati with me, and the person next to me is the same flight attendant speaks with him in a Marathi, then everybody is feeling like that we can have some sorts of comfortable. So that is another application with the help of natural language processing and deep learning. It's like the personalized some virtual AI attendant. Then this is a third application for the like AI industry or airline industry, but with the, let's say, the more focus on the tourism. So suppose you wanted to start a flight to a particular country. As a airline industry, I wanted to start a flight to some particular country. So of course, before starting, I need to estimate how many passengers or is there any tourism attraction available or available in that country or not. So what I usually will do, I will just provide the 3D virtual reality experience. So you can experience the, let's say, the Burj Khalifa, or the from the top of the Burj Khalifa, what the scene will look like, how the things will look like. And based on that, you can market that we have started a direct flight from, let's say, Kolkata to Dubai or Mumbai to Dubai. So you can target those kind of things with the help of these applications of AI. Another applications in the airline industry is like the optimum number of ground staff you can manage or optimum number of check-in counters. So during the Diwali vacations, we need a more number of check-in counters. During the Saturday, Sunday, sometimes we need more check-in counters. But during the Monday, Wednesday, Thursday, we may require the less number of check-in counters. So by that way, you can manage your ground staff as well as the check-in counters, because that comes from the data analytics. You unnecessarily use assign 15, let's say, ground staff, and there are hardly few passengers who are there to check in, and you are simply wasting. And sometimes during the festival seasons, we deputed only 5 ground staffs, but there are several passengers which are, so that's the problem. By having this data analytics using the AI, we can go with the optimum resource allocations. Sometimes overbooking is problem, so that we can also analyze and apply and solve using this data analytics. So broadly, we can see that we cannot imagine the applications where the deep learning is applicable. So you just think, and it might be possible that you can apply the deep learning. Now the thing is that whether to apply the deep learning and not to apply is a different question, because sometimes the problems can be solved using simple mathematics or statistical learning, sometimes the machine learning, and sometimes in deep learning. So not all the problems we should divert to the deep learning just because it is in the boom in the market, but that needs to be a conscious decision. So ultimately, when we see the overall AI, ML, and DL, there is some standardized flow that this all different, let's say, modalities are following. So first of all, we more or less try to capture the data. Then if the data are impure, then we clean them. That is part of the pre-processing. And sometimes the missing data are there. So we have to substitute that, or we have to remove those particular data. So that is what the pre-processing is the second stage. The third one is like the model training, where we give those data to the model, and it learns itself from the data. And since that model is now ready, we have to test that model. That is part of the, you can say, the evaluation, and based on the evaluation we can go for the course correction. So yeah, fine. So that is what we can say the improvised process. So again, this process, we can say we can make it a circular process instead of like a single one way. But the thing is that after improvisation, if required, we can go for the further data collection. We again pre-process them, again retest, and again improvise. So that improvisation process and this model will continue unless we are satisfied. Now this is a standardized flow that we are usually following. And so of course we have discussed about these different applications of the machine learning and deep learning. So I'm not going to much detail, but the thing to reintroduce this slide over here is that because we need to think what kind of applications that we can tackle. So the problems where there is no deterministic algorithm is available, or not even we can say the in the using the available complexity. That means sometimes we say that there is a deterministic algorithm is available, but the complexity is very high. Okay, it is like so not feasible. But sometimes we have that problems for which the deterministic algorithm is not possible. For example, if I say you want to calculate the interest that will be generated for a specific principal amount for a specific interest rate for a specific duration. So this is a deterministic problem. We have a very standardized equation to calculate how much interest you will earn for a given principal amount, given interest rate, and given duration. So this is a deterministic problem. For that, we don't have any problem. But suppose like the handwriting recognition, amnist data set, whether people are writing in a very different way the same number. If I'm let's say if I just give an example of number 2, then there are different versions of writing the number 2. There is a standard version we can write in this way, but people write in a different way. So handwriting recognition is not a deterministic problem. It's we don't have the deterministic algorithm available for that, and not with the huge complexity also. So there, okay, we can apply the machine learning and deep learning. Another kind of the situation that the problems which don't have a fixed solution and the goalposts keep changing, such as this spam filtering. Let us say we have the spam filter model, which may not work tomorrow also, or which may not work after the 1 month also, because from today and after the one, in between this 30 or 31 days, there are several different types of attacks might have been invented, which the current spam filter model may not capture. So the spam filter, okay, the solution is keep on changing. We cannot say that only you focus on the source email ID. Okay, sometimes we focus on the like the words which are abusive words or inappropriate. Sometimes the marketing words are written more frequently in the same email. So these are the hints which can provide, but these are not the only things. Okay, the spammers are now inventing in a different way without using any abusive word, without using any marketing keywords, without using any different things. Okay, like without using any, let's say, the marketing email ID. They are using some genuine email ID, but still they are trying to do their marketing. So filter is a very standard case. It's an ever-growing, we can say, learning process. Financial fraud is also that, where you cannot always that assume that this is the only way where the financial fraud is taken. The thing is that most of the systems are very secured. The hackers cannot directly attack on the system. Most of the financial frauds nowadays are using the social engineering. Social engineering means that sometimes they target those which are who are not very much like educated or not aware. So they have a telephonic call that we have won this prize. Okay, we have the lucky draw and you got the price. You just simply need to tell your credit card number and we will transfer the money. So that is a social engineering. By capturing those information, then they are doing those things. But direct attack on the system is still very difficult. But here the like so today is social engineering, tomorrow will be some another way they find to have the fraud. So the goalpost is keep changing. So here in this kind of situation for applications, we have to apply the machine learning and deep learning. The third one is the solution where solutions are individual specific or time dependent. So if we just give an example of the recommendation, so recommendation is a very personalized recommendation, individual specific. If I like, let's say the like suspense movies, it's not always possible that my wife is also will also be liking the same kind of movie. So the recommendation is a personalized choice, and there you cannot have the deterministic algorithm. You have to go with the specific recommendation to specific, and again the time dependent. So suppose if I example is my daughter is just 2.5 years old, and still I'm buying the diapers. Fine. So well, usually what I have experienced like when my daughter born, and after like, I just started seeing the type of advertisement which I get on the different websites. So sometimes, like not sometimes, but frequently they have the advertisement around the like this diaper has this much discount. Okay, this diaper is very convenient. So I was wondering that why they are giving me this kind of advertisement. So it's a time dependent. At this point of time, after 2.5 years, I am not in that much requirement of the diaper. So this advertisement, the type of advertisement has changed to for me also. So it's a individual specific as well as time dependent. Like based on your now I'm looking for model like buying a property. So there I have just seen in like half an hour below before that they are giving me different projects in surrounding my vicinity in Rajkot area. So that is the very beautiful, we can say the targeting advertisement we can say, and that is possible because of this machine learning and deep learning. The fourth one prediction based on the past as well as existing pattern. And there we all know that the prediction of the share prices is dependent on the current situation as well as the past history. So if the past is good and the currently they are going good, then obviously you can expect that the this market of that particular company will giving some sorts of return or not. Fine. So now what we need, because we have understood that where it is applied and in which situation to apply. So if you wanted to start from the beginning, okay, you need some sorts of essential tools for that. You need to have access to Git and GitHub because they have the ready to use the programs are available. So you don't start from the very scratch, but you can understand few of the existing models, and based on that, you just extend those models based on your understanding. You need to have understanding on the Python. You know how to use the Jupyter notebook. Then you have some uh, local softwares which you have installed in the local drive. You must have to learn some sorts of understanding on the NumPy, vector calculations, Panda curation. So these are the essential tools and knowledge that you require in order to start in the direction of the deep learning. So now we go a little bit into the conceptual part of this particular talk about the deep learning and it's how it is like progressing. So we all know like it all has started by mimicking the human brain. Sorry. So it all has started by mimicking the like human brain. So on the right hand side, we can see that there are the so dendrites are available and axons are available, and the same we have tried to mimic as part of the artificial neural network. So this is a like a natural neural network that is like we all have, and we have started mimicking that. So that is what's an artificial neural network. So before we go into the artificial neural network, we need to know how the things are working. So in any particular thing, if you see, okay, the features are very important. We as a human are also having the certain features like the height, okay, the color of the skin, we have two eyes, and we have the hair color. So then we have this eyebrow. So we have also the certain features, and based on that, we can differentiate this is a human, this is monkey, this is dog, like that. So each and every problem is also similarly must have the features that will help the model to learn the behavior. Fine. So the features are we can say the elements of your input vector, or we can say the number of features are equal to the number of the layer of the network. So let's say, for example, if you are giving, so in airline fare, if you want to predict the airline fare, so the number of seats availability, in which class you are traveling, the time of your journey, whether it's a holiday or it's a working day, the day of a journey, it's a Monday or Tuesday or the Saturday, Sunday, origin and the destination of your journey, then the seat preference. So these are the few features that help to identify what could be your airline fare. Traveling from Mumbai to Delhi has a certain fare than traveling from like Mumbai to, let's say, Zurich. Fine. So here the destination is obviously one of the factors that will target on the airline fare. Then the travel class, you're traveling a business class, economy class, the seat preference, traveling the aisle seats or the window seats. So day of a journey. So every those features will help us to identify the airline fare. Similarly, in the time detection, speech recognition, cancel detection. So we have the each and every problem. identify the features, use those features, train the model, and go for the prediction. Then the weights. Now, why we are discussing these features and weights? Because if you have seen the artificial neural networks, then there are the neurons, then there are the hidden layers, and there is the output layer. Fine. So here, this first input layer, we can say that each and every individual feature will get into the individual neurons. And now we have the several hidden layers, and then after we have the output layers. Now the weights will be helpful because not all the features are equally important. Fine. So for an airline fare prediction, the destination is an important feature. It's a highly important feature, we can say. The travel class is also an important feature, but there are other features also we have noticed. Okay, the number of seats. Okay, if you are booking one seat or if you are booking two seats, there may not be huge price difference you get. Okay, the seat preference, the price will be little more. Sometimes if the flight is empty, you won't get any price difference. For the same price, you get the aisle seat as well as the like the window seat. Fine. So there are some important features which are we can say which needs to be emphasized more. There are some features which are available, but they are not that much emphasized. So how do I formally define whether it's emphasized more or not? So that is based on the weights. I can give more weight to say that this feature is more important. Fine. I need to tell the model that what is important and what needs to be considered more and what needs not to be considered more. So accordingly, the model. So how I tell the model. So I will say that let's say I have the 0 to 1 scale. And on the 0 and 1 scale, I said that the travel class is zero point 0.7. The weight, let's say I assign zero point 0.7. So that is 70%. It's more important. Let's say the destination is like I assign weight zero point 0.9. So destination is more important in calculating airline. Right, so the weights corresponds to each feature. Either it's a zero, like the value is 0 0.1 or let's say zero point 0.9, but it is given to each and every. So weights denote how much the features matter in the model. Obviously, higher the weight of a particular feature means that that is more important in deciding the outcome of the model, right? So that is what we have the another understanding. So why the weight comes? So after the input layer where the each features are going, now they have to communicate with the hidden layer also, right? And there will be some sorts of calculation between the value of the input layer with the weight of that. So that will correspondingly produce the another equation. Like we can say the harmonized equation or the formula, which will generally goes towards the predicting the output. So usually in a ANN model, or we can say we don't know as a human, we don't know, right? Like to give the value zero point 0.7 or zero point 0.8 or zero point 0.3, no. So the weights are initially randomized. Fine, we can assign any random weights. Now, how the weights will be like converts? So based on the requirements. So suppose we have given the first sample of like all the features and the model has predicted certain price. Let's say the price will be 500 rupees for this particular flight. Now we have in the supervised learning, the actual output is also available. So our actual output, let's say 5,000 rupees, and our model has predicted 500 rupees. So now there is a huge gap between the prediction and the actual value. So that is we call as a error, or we can say the difference. So now that difference will be in the back propagation, will be propagated, and the weights will be gradually, let's say, updated. So again, let's say weight is updated. We have gone with the second sample, the prediction is made as let's say the 1500, actual is let's say 2500. So we have some sorts of reduce the error. So when we go back and forth for the several times, at some point the difference of the prediction actual will be negligible, or we can say it is under some threshold. So that threshold will be decided by the model designers and how much error you can compensate or how much error is uh, okay for you. So if this error comes consistently below that threshold, then we can say that our model is trained properly and it is predicting some sorts of the reasonable prediction. So now let's say you given the sample, the predicted is a 2300 and actually is a 2350. So now we can say that okay, my model is working correctly. And at that point, whatever the weights are there for each and every feature, then we can say trained weights. Our model is trained. So we can say the model is trained. That means our weights are identified, right? So we try to bring them to near optimal values so that they are able to fit the model well and can help us to predict the unseen values. So that is what important to understand. Now, when you see, okay, let me show you. This is the like a deep neural network, but this equation you can see here. Let's say yi cap minus yi. So that yi cap is the predicted value minus whatever the yi is the actual. But we can see that there is a square. Okay, the difference is an error. Let's say my predicted price is 500 and the actual value is 5,000. So the difference is 4,500. So that is the error. We know that my price prediction error is 4,500. But then why there is a need to square them? Because it will make the value very large. Okay, sometimes let's say the difference is in negative also. I have predicted, let's say 700, the actual price is 500. So again, there is a difference. So here, why we need to square? So most of the time, that is called as a loss function. So we are usually squaring the loss function, which considers the error difference. So there are two benefits of squaring them in that particular sum. So squaring will always give the positive value. So sometimes you give the negative. Okay. So like suppose you are trying to predict the age. Okay. So age cannot be a negative value. Okay. Everybody bonds it's a positive value for the age. So we cannot predict the age of a person -7. So if that is the case, then it's a problem. So we need always the answer in a positive. So the sum, when we square them, okay, we ruled out that possibility of getting the answer in negative, right? So that is what the first benefit of squaring. The another benefit of squaring is that it emphasizes the larger differences. Okay, that means that a feature that turn out to be both good and the bad. So we think in a different perspective of that how it emphasizes a larger difference. Fine. So suppose if I have predicted, let's say zero point 0.5, but the actual is zero point 0.7. So the difference is only zero point 0.2. But when I square them, okay, it will become 0.04. But let's say if I say predicted 5 and the actual is 7. So the difference is only 2. But when I square them, it will become 4. So we are emphasizing that this is a larger difference. Now say 100 and 200. Compared to 5 and 7, the difference is 2. Now 100 and 200. So we all know that the error difference between 100 and 200 is 100, and between 5 and 7 is only 2. But I want to emphasize that this one is a huge difference. So what I will do, I will square them. So squaring the 5 minus 7 will be 4. Squaring 100 minus 200 will be a very large difference. So I emphasize that in the second case, there is a more error. So that will also be benefit of squaring. Now, from this artificial neural network, we go towards the deep network. Fine. So again, more or less, we can say the initial architecture. We started with the same, like the one is the input layer, then several hidden layers. We have seen only two hidden layers here, and the output layer might be the one neuron or the set of the neurons, depending on the application. Now, first we understand how the things are working, and then we go towards how the deep learning has assisted in making it easy. So in the neural network, let's say we start with the one hidden layer, and in that hidden layer with one hidden neuron only. So contrary to this example, there are two hidden layers, and each hidden layer has a four hidden neurons. So in order to explain this with very complex, so what we assume that let us understand application where we have only one hidden layer. So we forget that we have the two hidden layers, only one hidden layer, and in that also let us assume that we have only one hidden neuron. So we take that and understand, and then we will try to generalize them. So again, the mean square error equation will be the same, which we are assuming, starting with the example of the airline fare prediction. So as I told you, the input in the input layer, each neuron is designating, or we can say representing, one corresponding feature. So we have, let us say, for example, we started with the five features. So in the input layer, we have five neurons starting from x1, x2 up to xy. And let's say the corresponding features are the airline size, engine type, number of engines, seating capacity, and fuel capacity. So now here the problem is to predict what will be the cost of the particular airplane. because let's say the Boeing 737 has a price different than the Boeing 747. So Boeing 737 has a seating capacity only 180 passengers. It says only single and it's a twin engine, but the limited capacity engine type is different. Engines are different. The fuel capacity is different. So accordingly, the cost of that aircraft will be also different. And my task is to predict the cost of the aircraft. I've taken these five important features I have identified, given them in this input neuron. Right, as I told you that let us assume for a simplicity one hidden layer, and in that layer we have only one hidden neuron designated as layer representing a Z, we can say Z1. Now I have mentioned the importance of the weight because we don't know out of these five features which one is important, which one is not important. So let's say we assign the numerical terminology notations W1 to W5, the weights associated with each feature x1 to xy. We initialize them as a randomly as we don't know which one is important and not important. So ultimately what happened, this hidden neuron must represent some value. And what is the representative value? Because all the five features are coming and that's neuron, and now instead of five features we have to represent the same using only the one neuron. So we need some sorts of calculation which will balance and give some effects of all the features. So there comes this formula, okay, that there we can say the W transpose X, very common formula we have. So Z1 is a representation of all the features and the corresponding it when we just sum those up. And in addition to that, we add the bias. Fine. So there is an important phenomena behind adding the bias. So in the subsequent slide, we have a separate explanation over that. But for now, let's not assume that we have added some bias. So now after that, we are applying whatever the value we get as part of the Z1, we apply the activation function. Now there is also a reason behind doing applying the activation function. We cannot take that value Z1 directly, but we have to just apply the activation function, and we then after we take of the prediction. So two important things we learn into the subsequent slide: importance of the bias, importance of the activation function behind the prediction. But for now, let us say assuming that we get some prediction y cap. Now y cap is our prediction, yi is our actual value. So if whatever the difference we have, we that is we call as a mean square error, and that will help us to just retrain the model, retrain the weights. Okay, so ultimately we can say that the y cap is what? Y cap is nothing but a g is the function of z1, and z1 is what? Z1 is nothing but z1 is this entire formula. So ultimately what I can replace this z1, okay, I can replace z1 with this entire formula, and this entire formula can be easily represented as w transpose x plus b, right? So y cap is a z inside the bracket w transpose x plus y. Now we let us understand the W transpose X. So y cap is the cost of the airline function. So why we are usually applying the W transpose X? Because let us say we have the two vectors available here. One is the feature vector, now there is a weight vector. So the feature vector is also, let's say the dimension is a 5 cross 1. If we say the weight vector is also kind of a vector 5 cross 1. So our requirement is that we have to multiply the feature value with the weight value. Now, if both are at the same dimension, 5 cross 1, 5 cross 1, then the multiplication of these two matrices is not possible. So for that, we need to change that vector to the, let's say, the horizontal vector, which is a row vector. Both are in the column vector, right? So one is a row vector, another is a column vector. So we let's say the W, like the feature we have made is a row vector. So now the dimension is changed to 1 cross 5, and this feature vector is the column vector because the 5 cross 1. So now we can have the thing is that 1 cross 5 is multiplied with 5 cross 1. So we get a 1 cross 1. That means a scalar value. And that is because we need only one value. We don't need a vector or we don't need a matrix. And that's why this W transpose X is given so that we can get a single value Z1. So this is a scalar, only a single value, not a vector or not a matrix, right? So that's what the purpose of doing this W transpose X. If you do in another way, then we can get a 5 cross 5 matrix. So we don't need a matrix, we don't need a single vector. So that is what the purpose. Now the activation function we have applied in the previous, let's say here. So here the activation function is z. Now why we cannot take this z1 value directly and just give it as part of the output? The thing is that okay, so output from every neuron is generated after applying the activation function. Fine, I like this value being considered as the input and output. So the main the thing is that applying the activation function is that we need to transform our input from one domain or from one space to the another space so that we can do some sorts of thresholding. Suppose example is I want to go for the binary classification. Fine, so I need to range them between 0 and 1 so that I can fix some threshold either at the point 5, point 6, point 3, wherever my threshold will be decided by me. But I need to transform those values into some domain, some space between 0 and 1. Now the thing is, you say that if you don't apply let's say the activation function, so your range can be any infinite range, and there it will be very difficult to get some sorts of calculation. So your output may be let's say aircraft cost, output may be 5 billion, your output can be a 3 million euros, your output can be 10,000 or whatever. So in order to like deal with the huge range, it's quite difficult. But all the numbers, let's say we have transform normalize between the 0 and 1. So how we can normalize them or how we can transform, that is being done by the activation function. And the important criteria is that the activation function must be a differentiable, right? And non-linear activation function help us to bring the non-linearity into the system. So the benefit of the each and every real life problems are non-linear. Okay, you take any problem and those are the non-linear problems. So that help us to bring them into the non-linear. So that is what the benefit of activation function. Most popular activation function previously it was a value. Now we have the leaky, we can say leaky value also is there. So sigmoid, softmax. There are several uh, Google we have for the different purpose for the different activation functions. We have also applied the bias. So what was the need? Can't we just take the input features, just take the weights, and that will be our output like this one. Here at the end we have added a bias. You can see that, and here we have taken the value as a one as part of the bias. So what was the need? So okay, the bias value, okay, will allow the activation function to be shifted to the left or right to better fit the data. Fine. It is not always possible that your data will pass through zero. On the top figure, you can see that there are three different, let's say, the functions we have applied, and all are like passing through zero in the center. You can see here, this is zero, and all are passing through zero. But in actual real life cases, it's not necessary things will always pass on zero. Sometimes, okay, our data pattern is same. You can see that it is in a same like way in the figure just below it, but those are not passing through zero. So, like if you do not apply the bias, then it won't allow us that mobility to shift our activation function to left and right. It always force them to pass through zero, and that is not desired scenario. Okay, so that will be the benefit of adding the bias. Okay, so it so that you can have the better fit to your data. And the bias only influences the output values. Okay, it doesn't have any interaction with the actual input data, and they are independent. Okay, from the previous output values also. So that is like it is not affecting the previous output. It is not affecting the input, but it has provide some sorts of the flexibility we can say. So that is what the purpose of adding the bias. Now we move towards the things for taking a specific example and moving towards from ANN to DNN, our journey from ANN to deep learning. So we started with this ANN. Okay, we taken this example of one neuron. We understood this, the activation function and bias. Now let us take an example of an image, right? Let's say image which red, green, and blue, three okay channels, and the size, let's say 8 cross 8, and we have the three layers, so that is multiplied by 3. So now let's say we going for the very specific example. So let us say in this image, okay, each pixel is representing some value, kind of an intensity value, or we can understand that way. So first of all, since we have seen our neural network, there is a one input layer. Input layer is form of the vector, and this image is in the form of, we can say, the matrix. And obvious, we can see the matrix now it's become a tensor because it has added a third dimension also. So like we have to transform this tensor into the vector, because you can see each pixel is a representation of one feature. But that problem is different. Image in image, each pixel is representing the one feature. So first of all, we have to transform this, we can say, the tensor into the vector. So how we are doing? Let's say we have taken this first one. So from 23, 56, we all have then transform into the vector up to, let's say, the last value is 09. Then we take the second channel. We start with the 37 and with 66, and we go with the third channel 41. We go with the last value 32. So now we have changed them into the input vector having the 192 values, because 8 cross 8 cross 30. Okay, so 192 input values we have in this image. Now we use, because ultimately now one requirement has been satisfied, that you have the input layer available in a vector form and all the pixels are representing the particular, let's say, the features. Now our shape of the input, okay, our shape of the input will be in the form of the n cross m. We have seen that, okay, where you can see the number of data points, like the representation, like the x1 1 and the x. Okay, so in the, let's say, the we are focusing on the particular, let's say, the red color. Okay, so like the all the pixel value in the, let's say, the red channel will be listed, then the yellow channel will be listed, and the third, let's say, the blue channel will be, sorry, green channel and the blue channel will be listed in that way. So our input size, shape of the input will be in n cross m, and the shape of our outputs is, let's say, we are going for the binary classification. Okay, so like the shape will be like this way. So for each image, okay, now you can see that we have provided, let's say, the 100 images, and each image is representing a vector. So this is, we can say, okay, the first image, first pixel value, first image, second pixel value, first image, third pixel value. So this is, let's say, the first image entire vector. Then we have the second image, third image, fourth image. Let's say we have the m images for the training of the model, right? So our input is a n cross m, where each image is of the same size. If you have the 8 cross 8 is the size of image, then all the training images will be of the same size, 8 cross m, 8 cross 8. So let's say we have the n number of input 192. Let's say in the previous case we have assumed 192. So we have all the images are represented in a 192 input vector, and we have such m images. So n cross input. Now for each image, let us say we have to go for the prediction. So let's say for this one, for the x1, we have the corresponding output is a y1. For the x2, we have, let's say, the corresponding prediction is a y2. So likewise, we have this y1 is a prediction for the first image, y2 is a prediction for the second image. So this is, let's say, the 1 cross m is over the shape of the output. Fine. Now we go a bit into the mathematics of that particular things, how they are working. So now we have to define the things in terms of the, like, the layers. Okay, so previously, let's say this is the features x1, x2, x3. We designate as, let's say, layer 0, or we can say the input layer. The next one is hidden layer. Let us designate with A1. Now the thing that in the previous case we have only one hidden neuron, but here in this case we have four hidden neurons represented as Z1, Z2, Z3, and Z4. And all the input layer neurons will interact with all the hidden layer neurons. Fine. So how the things will be? X1 is also going to the Z1, X1 is also going to the Z2, and X1 is not only going, but its corresponding weight W1 will also go there. So what will be our formula? Will be that there is the first neuron, okay, what in the first neuron in the first layer. Okay, so Z1 1 in the first neuron first layer. This is a Z1 2. That means the first neuron in the second layer 2. So calculation we have seen that W transpose X plus B. Okay, in the first, this is the first neuron Z1. So our W1 is also represented, and this one represents the corresponding layer. So W1 1 transpose X plus. Okay, of course the we have this bias also associated with that. So okay, hidden neuron there is the associated bias. It is not the layer wise, it's a neuron wise. So we have four hidden neurons, so we have the four hidden bias also. After that we have the corresponding four activation function we apply, and that again now corresponds to the next hidden layer. So now, like in the middle layer, let's say the four neurons, so all those four neurons will communicate with all the hidden layer neurons in the second hidden layer, and finally we have the like the prediction y cap. So these are the terminologies we are just representing them. Fine. Now, okay, finally we are applying like some sorts of like the activation function. So that can be, we can say, if we are going for the MNIST data classification, so we have the to classify between the 0 and 9. So there are 10 classes are there. So accordingly, we have to apply, let's say, the softmax function, because when we have the multiple categories, then the softmax function is useful. Here we have an example that suppose you want to categorize any picture into four predefined classes. So in a binary classification, we can apply the sigmoid function. If there's a multi-class classification, you can apply this function. Fine. So let's say if you have the four categories like scene, animals, human, and vehicles, then accordingly we have that softmax function which will allow us to predict for the four different outputs. Fine. So this is the forward and backward functions, okay, so that you can train your models from the like train your weights accordingly. So this is a like the forward function and the backward function which will allow us to, based on the margin of errors, you can adjust the weights. Now from that ANN we have studied the convolutional neural network. Now, so what is the difference we are getting? The motivation is that these are the typical applications we have seen. Convolutional neural network is applying, and it has successfully done that. Now the motivation of going from avoiding this as like artificial neural network is that here given in this very simple example of a 16 cross 16 image. Let's say since you can just multiply 16 cross 16, so 256, and we cannot give matrix as an input, we have to change into the vector. So vector means that we have the 256 neurons we have to take as a part of the input layer, and then let's we have some sorts of hidden layers are there. And since our problem is to recognize the alphabet, so we have 26 alphabet. So accordingly we have to have the 26 different neurons in the output layer. If we are using MNIST dataset for the digit recognition, so digits are 0 to 9. So we have to take 10 different neurons in the output layer. If we have only binary classification like yes and no, so you only one neuron which will take. So how many neurons we take in the output layer will depends on our application. So here we have the A to Z. So 26 neurons are there which is required. Now you can see what we have understood that with each hidden neuron there is a corresponding bias is also associated. Okay, so since let us say example, for an example, we have 100 neurons are there in the hidden layer. So we have corresponding 100 bias also there. Now each neuron in the input layer is communicating with each hidden neuron in the hidden layer. So how many computations will be there? There will be 256 in the input, and each of them are communicating with the 100 neurons in the 100 layers. So 256 multiplied by 100, plus we have the 100 bias associated with each hidden neuron, right? Now from here you can see these 100 neurons we have on the output layer, so that will be communicated. So 100 multiplied by 26 output neurons, and each output neuron is again having the bias. So 26 bias will be there. So when we will roughly like do the calculation, you will have the 28,236. That means number of trainable parameters are there for just a small image of 16 cross 16 size. You can assume this a huge number of trainable parameters are there. We need to go for the computation, and ultimately it will be a very costly applications for them. So ANN, we can say we cannot assume that only one hidden layer. Okay, there might be a range of hidden layers you can have, and each hidden layer might have the several hidden neurons. So if we just keep on multiplying, then it requires huge computational cost for a simple application of the simple image itself. So that many too many parameters we have, and we know it is good to learn a small model rather than a very complex model. So from this fully connected model, okay, there is the first question that do we really need all those ages? Do we really need to communicate one neuron with all the neurons in the next layer? Is it obvious? Is it required? That is what the fundamental question. And is this possible that few of the ages we can simply discard and still get the efficient result? Is it possible or not? So there is an analogy of doing this. Yes, it is possible. We can do that, and that can be better understood by this particular video. Okay, so in this video, if we can see that even if we remove certain information, we can still recognize a particular thing. Okay, so let me run this video for briefly. Now you can see we can still detect the dog even if we have removed the half of the information. This time you can see we have removed a quarter of the information, but still we detect that this is the dog. So that indicates that we should not take all the information. It's not required for us to consider all the information because there are several redundant things are presented. So even if we remove the certain information, still our model can detect. It is possible. So from that, that is what the difference between the CNNs and the ANNs. That is called as the convolutional neural network and the artificial neural network. The first is that the ANNs suffer from the convolutionality. That means we can say when it comes to high resolution image, then you have the several like the trainable parameters that you need, but still we can avoid this by using the filters, or we can say the exploiting the spatial locality. So spatial locality we have just seen in the previous video that the nearby pixels are representing the more or less same information. So if I you take my picture of this particular face, so my all the let's say the pixel values in the nearby this area will represent the same things. All the like they are more or less having the same pixel value. The only difference will be more on the let's say on these edges, which will give some sorts of curves and have the edge. So from this edge, the person can understand from here the nose will start. Otherwise, the rest of the thing is like from here we can say here that the mustache will start. So those edges are important. Otherwise, we can just have the more or less same information and we can exploit that spatial locality. So there comes the concept of the convolution. It's just a pointwise multiplication of the two functions, and we can sometimes it's called as the convolved feature or activation map or the feature map. So let us understand how the convolution process has been done. So now you can see that why we are doing this. We are doing this because there is a curse of dimensionality production, and that we can avoid using the filters by exploiting the. So filters are nothing but a this convolved feature or feature map, we can say. So here we have used some certain feature of 3 cross 3 as example. On the left hand side, we have the 6 cross 6 matrix. Let us assume that for a while it's an image. Now, what is the benefit of applying the convolution? So you can see that we have transformed the 6 cross 6 matrix into the 4 cross 4 one. by applying but still retaining the major information. So let me run this convolution filter 3 cross 3 on this matrix to generate the another matrix. So here when I will just map that filter, so what will happen? I'm just multiplying. Okay, so 3 is multiplied with 1, 1 will be multiplied with 1, 2 will be multiplied with 1, and similarly the other things. So since we have the 0 over here, so there is no contribution of the like the middle cell, so all the values will be here positive, all the values has been negative. So 3 plus 1 is 4, plus 2 is 6, and here it will be a minus 1, minus 8, minus 9, and minus 2, so minus 11. So 6 minus 11, so my value will be 5. So ultimately what we are trying to do, we are representing the same information by convolving them. Right, so you can see we just move one more, apply that filter. So we are scanning the filter on the entire images and we are generating like this way. So this is a convolution example, exploiting the spatial locality like this way. Right. Now, what to do with this particular like the feature map, or we can say convolved filter? Why it is being used? So as I told you that when you are exploiting the spatial locality where the nearby pixels are representing more or less same values, but the important things are to detect the edges, whether it's a vertical edge or horizontal edge or any non-linear edge. So those things are very important for the detection. And there the role of the filters comes. So the different filters will help us to identify the different edges. So suppose in any random image, you want to identify and detect all the vertical edges, then your filters would be like something like this: 111, 000, -1, -1, -1. If you take this filter and just apply that filter to any random image, it will identify vertical images or vertical edges in that image. So example, let's say 6 cross is 36, let's say the pixel is image size, and I am applying this particular filter. So what it will do, it will identify, okay, it will be converted into 6 cross 6 will be converted into the 4 cross 4. So here you can identify, you can see that here there is a vertical edge, the like the pixel value drastically changed from 10 to 0. So that pixel value drastic change indicates that there should be some sorts of edge. Since this is a vertical edge and we applied this filter, it has been defined by this. You can see it has bifurcated them. So that is what the purpose of the convolution uh, feature. And this is the, let's say, also one of the motivation here also. That means in the ANN you required 576 parameters, but by using this nine, by using this just nine 3 cross 3, let's say convolution feature map, we have successfully detected this vertical edge. So we have reduced a significant number of parameters in the CNN. So similarly, we have several different filters available: horizontal filters to detect the horizontal edges, subtle filters, core filters for the different applications. So that we can use and as part of the CNN and apply them. So more intuition, if you just wanted to get, then suppose I wanted to detect it's not a vertical edge, it's not a horizontal edge, but it's, let's say, the non-linear edge. So how can I identify? Okay, you can see that after having this like applying this convolution filter and moving them across the edge, it has successfully, you can see that bifurcated and identified this particular edge. So that is what the real applications we are having. After this convolved, let's say, filter, we can also use the padding, because you can see in the previous our input image is a 6 cross 6 size, but output we got a 4 cross 4, and that is not appropriate when we are dealing with the real life, that somebody will give the input or image and we always get the reduced image size. So that is not like appropriate. So we can go with the padding. So the padding will help us to preserve the original dimensions of the input when we are getting the output. So that means my purpose is that if my input image is 5 cross 5, then after applying this convolution feature map, my output should be also 5 cross 5 without appending. So you can append the zeros on the outer layer, fine, and apply this particular filter. Now the number of zero layers depend upon the size of the kernel. So this filter map is also called as a kernel. There are the different terminologies. So it depends on the kernel size. So here an example is given that let us say 6 cross 6 original image size, and we can say the n cross n, and we have done the padding of 1. Padding is equal to 1, so that means I have added one outer layer. So now this 6 cross 6 has become 8 cross 8. My kernel size, or you can say the filter size, is 3 cross 3. So what I need that my output should be also of the same size, 6 cross 6. Fine, and the kernel is a 3 cross 3. So how to do that? So you need to just go for the simple mathematics where you can see the difference. So here what we are trying to do, we are trying from, let's say, n minus f plus 1 cross n minus f plus 1 to this n plus 2p minus f plus 1 cross n plus 2p minus f plus 1. We have to go to that direction. Fine. So you can see that here the n is a value, let's say 6, f is a value of 3. So 6 minus 3 is a 3 plus 1 is a 4. Fine. So we can see that the, let's say, 6 minus 3, so 4 cross 4, 2 here become as a n is equal to again 6 plus 2p. So here the padding value. So how much padding is those? So padding is equal to 1, let's say. So n is equal to 6 plus padding value is, let's say, 1. So 6 plus 2 is 8 minus f. So 8 minus 3 is 5 plus 1 is a 6, right? So here we can go, okay, we have taken the example of 6 cross 6 to 8 cross 8, but here we have gone from the 4 cross 4 to 6 cross 6. So this is a valid transition we can get based on this padding. Now there is also the concept of the stride. Fine. So because sometimes we can also require only the info, like if we just go each and every row by row, okay, then again the matrix will be having the more size. So sometimes need to go, we can also skip some of the rows and some of the column also, because you can see that video we have first of all remove the 50% information, still we can identify. Then after we have removed further 50% information, and still we can identify the dogs. So it's not necessary that you have to scan the entire row and columns, but you can skip. So how you are skipping? Using the stride. Okay, here's a 6 cross 6 image, we have 3 cross 3 filter. So we can run this stride. So if I just, let's say, apply this particular values, then for the first one you get the minus 5. Then you are, let's say, having this stride s is equal to 3. So that means you are skipping 1 2, that means 1 2 and 3, and again you are start with this area up to 274 931 513, where you again apply the convolution filter, you get the value 8, then minus 3 and minus 16 likewise. So this entire 6 matrix is represented the same value representation as a 2 cross 2 filter, 2 cross 2 output matrix. So there we are using the stride. Now the thing is that we don't have only one channel, we have the multiple channels. So for each channel we have the corresponding filters, the padding, the stride also, and then we have the output layers. So here again, for the each and every filter we have the corresponding output is also available for the given input size. So that process will continue. Now the thing is that we have to correlate with that with the actual our process. So first of all, in ANN, what we are doing, we will just simply have the input vector, we have the weight matrix, we calculated and generated one corresponding value z1, then we apply the activation function. Here we are not doing that process, but here we are applying just a convolution filter map. So for that, for each filter map, we apply the function, we add the bias, and finally get the output. So that is the process we have to again now follow. Now the pooling is also one of the part. You can see that in the CNN layers there are some pooling layers are also there. Max pooling, mean pooling is also there. So in the what the pooling layers we are doing, we are more or less representing the maximum value of the pixel rather than considering all the values. So here if I just apply the filter of 2, for instance, maximum value is 8, Here the maximum value is 9 in this 4 pixel. Here the maximum value is again 9. And the last, how the maximum value is 4. So max pooling is also applied in a different situation to get the maximum representation of in that spatial locality. If you are in the mean pooling, then you get the mean value, and if you are applying the average pooling, then you just calculate those and presenting those average. So this is pooling. Finally, once you know the concept of, let's say, the padding, then stride, the max, and this pooling, etc., you can design your own architecture for the deep learning. So here, the AlexNet is example is given. Okay, we all know that the AlexNet is used for this image classification into the different categories. And what was the like the understanding over there here? So let's say for them the image size is 227 cross 227, and there are three channels. So three are the, let's say, the depth, or we can say the channels. So they have applied this successfully, like subsequently the some layers, max pooling. Then that's what to be need to be take the different size of the max pooling. That depends. So after the certain layers, then after they have applied this fully connected neural network, and finally you have get the output layer soft ranks, which has the let's say the 1,000 classes. So corresponding, we can say the 1,000 neuron layers. So here you can see that there are the stride s is equal to use 4, and the filter is used as 11 cross 11. So when you apply this filter 11 cross 11 on this image, you get the roughly the size of the next matrix, and we can say the next tensor of the size 55 cross 55. And likewise you can have the subsequent layers for that analysis. So here, after that, they have the fully connected neural network, which will help them to calculate the predict for the images for this across the 1,000 classes. So this is a very well-known problem and available on the public data set is also available for them. So how we can understand this AlexNet in detail? So you can see here we have this 11 cross 11 filter map which are running across in 227 cross 227 size and across the three layers, and the stride is equal to 4. Fine, so we can have, let's say, 227. Now how we are calculating, we have used this previous equation also. So it depends on the filter size. What will be your output? That depends on the filter map. If you don't recall, then let me just go to the few slides back. Here, okay, there is a, wait, yes, here we have an equation that what will be your output size, that will depend on the size of the filter. Fine, so we have that equation is available, n minus f plus 1. So we can use that, okay, to understand this one. So we have this n minus f plus 1 here, 227, and that is the n, 11 is the size. And since we are also using the stride, that means we are skipping the 4 rows, again 4 columns also. So that we need to divide by that. So two, that means, and then plus 1. So ultimately 227 minus 11. Actually, we have the n minus f plus 1 directly without striding. But we have, when we are using striding, so n minus f divided by the stride number plus 1. That will be our size. So 227 minus 11 divided by 4 plus 1. When we do, we get the 55 cross 55. So that is what we have transformed the size from 227 to 227 55. Then again they have applied the okay, max pool layer with the 3 cross 3 is the filter, and the stride is by 2. So again 55 minus 3 divided by 2 plus 1. So you get the 27 cross 27. Then again they have applied the padding. So the padding equation will move. So accordingly, what to choose here, the stride value, and what to choose as a convolution filter size on us. So this is the AlexNet architecture. They have decided in this way. You can have your own understanding and design a different architecture, like either to take 11 cross 11 or 15 cross 15. So that we need to work out. And finally, you can apply design your own architecture in a similar way. So this is the understanding of the entire AlexNet architecture. And this is we can see can understand the basic deep learning how it is working. What is the role of the padding? What is the role of the stride? What is the role of the convolution feature? How they are minimizing the number of trainable parameters. So we can see from this 227 cross 227 multiply by 8 we directly apply to the ANN, then it's a huge problem. So what we are trying to do, we are gradually minimizing the information by applying the pooling layer, max pooling layer, then convolutioning the process, convolutional layer, then pooling layer. So by doing that, getting this, reducing the information and exploiting the spatial locality. And once we are satisfied that the informations are available, then we can apply the fully connected neural network and finally the activation function to get the final output. So this is the role of the deep learning, and to be specific into the convolutional neural network that help us to reduce the number of trainable parameters that we train, and thereby we are getting the efficient results. So that is what the journey of deep learning. And we have so far several famous CNN models are there. We have this ResNet, VGG 16, then MobileNet, and many more then after also invented. So that is what my explanation from this today's class. So we started with the understanding of the deep learning applications, then the AN into this transition into the CNN, the motivation behind transition, exploiting the spatial locality. That is it good to exploit the spatial locality, and by exploiting we can reduce the number of trainable parameters, and thereby we can successfully apply the deep learning. So that is what the my today's let's say talk. If we have questions, then I will be happy to address them.
Thank you so much, sir, for your wonderful experience you have shared with us. Uh, yes, one question from Dileshwar Pandey, sir.
Yes, please.
Dilkeshwar Pandey, sir. Okay.
Yeah, nothing is audible to me if somebody is speaking. I don't know if anybody is speaking or not.
Sir, please just a second.
Good afternoon, sir.
Yes, yes, please.
Dr. Hiran, whenever we have to do real practical, how we should decide the filter size and what should be the coefficient of that? Maybe like vertical, horizontal, but how we can, looking at the image, we can know which filter we should take. Yeah, trial and error only.
Yes, it's a very important question, and it still is a research question because just by looking at the images, nobody can tell us that what should be the filter size. But more or less, we can see it's a general idea. Okay, so like we can think in a different way. Like these are the standard filters available. So like we are applying the filter based on our like of course we can have the different requirement, but we just go with the trial and error. That is like the question which I have also addressed here, like how whether to choose this 11 cross 11 or whether to choose 9 cross 9, right? That is depend on our understanding of the deep learning process. Suppose like by applying this 11 cross 11 filter, we are exploiting the spatial locality, but applying this 9 cross 9 filter, we have lost some of the information. So great, like you cannot, if there is a standard equation, then everybody is doing this deep learning, but that comes with the experience only. We can just start with the numbers, and then if the results are not appropriate, then we have to accordingly adjust. But the thing is that sometimes you can see in the ANN we have the weights, initially decide randomize, then based on the back propagation, the machine was learning. So similarly, we are doing the process over here. So we can see the trial and error, but with the experience, your trial and error will reduce the number of choices. But to the best of the
Right,
thing
sir.
is that the thing is over here that we don't have the thumb rule here, because if there is a thumb rule, then we cannot have the different architectures also. Different architectures are possible because of the people are thinking in a different way, that this much special locality information I should explore in this particular layer. After max pooling, whether I should continue to apply another max pooling or simply go with the process. So we have the different combinations are available for that reason.
Okay, sir. Thank you.
Okay, anybody else who want to ask questions? Suraj sir is asking some questions, sir.
Sir, I want to know the difference between this ANN, DNN, CNN, and RNN, and in which field or which type of data set we are using these four types of network.
So ANN, we are like we are using the ANN, and we can also apply the ANN on these images, or as well as we have this information of the like feature kind of information. So in a CNN, we are not giving the explicit features like in the airline price prediction like that. But the thing is that we have to understand why we require the CNN. In ANN, the concept is network. So the problem is very common. That's curse of dimensionality, and we are not exploiting the spatial locality. Even if, like, say, if I consider all the pixels, there is no reason to consider all the pixels, because if we can take an example, the nearby pixels are more or less representing the same information. So by using this CNN, and there is a the things are there striding. Okay, by using the CNN and even the striding, we are removing the certain information, but still retain the, we are removing the data, but still retaining the information. So CNN, we can say we can apply on most of the like the image kind of applications, and RNN is mostly suitable for this. I mean to say that recurrent neural network. So usually we apply them into natural language processing. So for the RNN, there is another like we have the slides available. So for that, we require one more hour to understand. So that's why I didn't include them into this. But yes, you can have this RNN applications available for this language modeling and word level modeling, like those NLP, natural language processing, mostly applied there.
Okay, I hope Suraj sir got his answer.
Yes, sir, I got. And sir, what are the languages preferred for this neural network?
Sorry, what languages?
Yes, sir. What languages are preferred for the implementation of this neural network, like
Yes,
Python? And is there
yes,
any?
yes. You can mostly, if you go with the Python, then the benefit is that you get the larger community support, because most of the implementations in this area, and there is strong Python community is there. So if we explore other languages, that's not a problem. But when it comes to the community support, then we get a little community support, and that's where we cannot advance our research. So the thing is that most of these projects available in GitHub and on its online community, you have this strong community support. So my preference will be always for the Python, but people are also doing in the R language also. But it's the individual choice in which you are comfortable. If somebody will tell me, then I will definitely go with the Python.
So in Python, we sometimes we are installing it like PyCharm and other things, and sometimes we can also use like Google Colab and other laboratory. Then what is the difference between these interpreters?
The difference is that you have the like the of course computation cost. If we are installing our local system, then our local system has the limited computation facility available. If we are using some cloud-based support like Google Colab or this Microsoft one, then we can get the more powerful computational CPUs, etc. And that is what the otherwise the same thing you can do, provided you have the we have the supercomputer facility in our university or organization, where the computation power is available. We can run the same application. There is no difference in the output. Only the difference is that one is on a cloud and another is on a local system. So that is what the primary, I can say, the difference.
Okay, sir. Thank you, sir. Thank
Thank
you.
you very much.
Thank you so much, Dr. Thakkar. Sir, I hope you share your PPT with us.
Sure. Yeah,
Thank
I
you
will.
so much, sir, for your session.
Thank you
Uh,
very much for inviting me, and it's a pleasure me to deliver a talk here, and the audience is also very good. Thank you very much.
Thank you, sir. Participants, I want to tell you that the feedback link is still active. So please give your feedback and quiz also. Thank you so much. This is the end of today's session. We will meet tomorrow morning at 10 a.m. sharp with another session. So thank you so much, all the participants and our today's speaker. Thank you, sir.
Thank you very much.
Hello.
Hello. Yes, sir.
Hello, ma'am. When we